Hello children, how are you all? Hope you all are doing well. This is Krishnamurthy. You can call me as VKM, your chemistry faculty working at Basidia. In the previous lecture, we had discussed about classification and nomenclature of amines. In this session, we are going to talk about preparation of amines. How do you prepare the amines? We are going to talk about the preparation methods for the amines. Simple amines like methylamine and ethylamine preparation methods will be discussed here. Even if any secondary amines and tertiary amines are there, those preparation methods also will be discussed in this session. Let's talk about first preparation method of amines, that is reduction of nitro compounds. Reduction of nitro compounds. Reduction means addition of hydrogen and removal of oxidation, removal of oxygens. Addition of hydrogens and removal of oxygens is called reduction. In nitro group that is NO2, in nitro group oxygen is removed and hydrogen is added. And for reduction, obviously we require reducing agents, right? Reducing agents which are used for this conversion is hydrogen in the presence of nickel or platinum or palladium. It is the one of the reducing agent, and Sn plus HCl, tin plus hydrochloric acid, or Fe plus HCl, iron plus hydrochloric acid. That is most preferable reagent compared to Sn plus HCl. Fe plus HCl is most preferable reagent. FeCl2 will be formed here in that reaction. Fe plus HCl will give you FeCl2 that can be hydrolyzed easily. Now if you see the reaction here, we have C6H5NO2. This is called nitrobenzene. Nitrobenzene on reduction with H2, palladium or nickel, anything can be taken. It gives you C6H5 and H2. This is called aniline. You can use even Sn plus HCl or Fe plus HCl also can be used. So nitrobenzene can be reduced to aniline. Nitrobenzene can be reduced to aniline by these reducing agents. It is the first preparation method can be given. And second preparation method is ammonolysis of alkyl halides. Ammonolysis of alkyl halides. Alkyl halides, what is the general formula? Rx. X is most electronegative and its bond can be polarized towards X. And we have ammonia. So nitrogen is having lone pair. This lone pair will be given to R because R is electron deficient. Then it forms RNH3 plus and X minus. So this is ammonium salt. It is ammonium salt. A substituted ammonium salt you can say. And this reaction generally, this reaction is carried out at 373 Kelvin. Around 100 degrees Celsius, we used to carry out this reaction. Actually, in this reaction, what will happen? In alkyl halide, CX bond will be there, no? That cleavage of CX bond by ammonia takes place. That reaction is called ammonolysis. Ammono means ammonia. Lysis means breaking. Which bond you are breaking? CX bond you are breaking with the help of ammonia molecule. That reaction is called as ammonolysis. Hope you understand. Let's see all the reactions. RNH2. Will you allow me to write RNH2 as RNHH? Okay, thank you. And reacts with the alkyl halide. Reacts with the alkyl halide. That you can write it as XR. So what will happen? This H and X has been removed. So now what we have taken initially, we have taken primary amine. This is primary amine. How to get this primary amine? To get this primary amine, I have to take ammonia plus Rx, alkyl halide. HX can be removed. HX can be removed. What we got it? RNH2 we got it. That is primary amine. That primary amine is treated with another mole of alkyl halide and HX can be removed. It gives RNHR, which is secondary amine. And this secondary amine is treated with another mole of Rx. So what will happen? This HX can be removed. Right? And then you will get RNRR. Our nitrogen is connected to 3 alkyl groups, hence it is called as 3-degree amine. And furtherly, if it is treated with Rx, so it is R plus X minus, lone pair of electrons can be given to R plus, and then it forms RNRR, and nitrogen forms a dative bond with R, it develops a positive charge and X minus. So I can write the same as R4 N plus X minus, which is called as quaternary ammonium salt. Which is called as quaternary ammonium salt. R4 N plus X minus is called quaternary ammonium salt. So ammonia gives primary amine. Primary amine and further treatment with alkyl halide will give secondary. Secondary will give furtherly tertiary. Tertiary will give quaternary ammonium salt. So if you observe that, so we get a mixture of amines in this reaction. That is the biggest drawback of this reaction. When we get a mixture of amines, the major yield of the primary amine gets reduced. So that's why this is not a preferable reaction, right? If you want to prepare it in bulk amounts, or in commercially if you want to make amines, primary amines, it is not the preferable method. For suppose if you take excess of alkyl halide, then you will be getting this mixture of products. That is a disadvantage of this reaction. And next, if you observe the continuation of the previous reaction, we have taken alkyl halides, right, as Rx. Which alkyl halide is more reactive? Order of reactivity, if you observe, that is Ri is greater than, Rbr is greater than Rcl. So we can break the Ri bond. Ci bond we can break it easily compared to Cbr and compared to Ccl. So Ri is involved in the reaction rapidly. And whatever we got the ammonium salt RNH3 plus X at the last. Similarly, what we got ammonium salt RNH3 plus X, if it is treated with NaOH, you will get RNH2 plus H2O and NaX. You will get RNH2 plus H2O and NaX. We can get our primary amine. So, by treatment of that ammonium salt with a strong base, that free amine is obtained. That free amine is nothing but primary amine is obtained. We can regenerate that primary amine. Hope you understand. The next reaction we have, third one, it is reduction of nitriles. Reduction of nitriles. Nitriles are nothing but cyanides only. Cyanides IUPAC name is nitriles. Cyanide functional group formula CN. Cyanide functional group formula CN, and these nitriles are subjected to reduction. That can be carried out with the help of a reducing agent. The reducing agent here we are using is LiAlH4. Lithium aluminum hydride is the preferable reducing agent. So Rc triple bond N with lithium aluminum hydride, or you can use sodium in ethyl alcohol, but most preferable reagent is lithium aluminum hydride, which is an example of a strong reducing agent. So what will happen initially, this triple bond is there. The triple bond subjected to breaking. If it is subjected to breaking and add 4 nascent hydrogens, so for one bond, 2 nascent hydrogens. For 2 bonds means for double bond, total 4 nascent hydrogens. That gives you RCH2 NH2. Simply we have added hydrogens and triple bond has been converted into double and double bond has been converted into single bond. Finally, we got RCH2 NH2. It is primary amine. If you take an example, CH3C triple bond N, methyl cyanide is subjected to reduction. It will give you CH3, CH2, NH2. It is called ethylamine. Hope you understand. Next, we have reduction of amides. Amides are those compounds which are having CONH2 functional group. CONH2 functional group containing compounds are amides. Now, these amides on reduction with lithium aluminum hydride yields amine. Take a general reaction, RCO NH2 with lithium aluminum hydride followed by hydrolysis, of course. Lysis is required because we are breaking bond. That's why water is required. So RCONH2 in the sense, this bond we are breaking it. If you break that bond, so this side H we are adding, okay, and this side H we are adding. And so we are breaking that another bond also. Another bond we are breaking, add H here, add H here. Then we are removing the water and you will get RCH2 NH2. A primary amine is obtained from amide. If you take an example, CH3CONH2, this is called acetamide. And undergoing reduction with lithium aluminum hydride, it gives CH3CH2 NH2. This is called ethylamine. An example of primary amine. And next, a very important reaction we have, that is Gabriel phthalimide synthesis. The most important reaction among all of the preparation methods from amines chapter. For competitive examinations, it is very important. Phthalimide, we are taking it as a substrate and it was discovered by Gabriel. That's why the synthesis is said to be Gabriel phthalimide synthesis. It is a method for preparing primary amines, suitable method for preparing primary amines. That too, aliphatic amines. Aliphatic amines can be synthesized in good yield. Aliphatic amines can be synthesized. Okay, not aromatic amines, not for the aromatic primary amines, it is for aliphatic amines. So we will take first phthalimide, that is C double bond O, NH. Treated with a base, that is KOH. So there is an acidic hydrogen, right? This hydrogen is acidic. And this acidic hydrogen abstracted by the base, removed as water. If it is removed as water, you get a salt. Acid has been treated with the base, you will get a salt. This is C double bond O, and it is N, and it is minus, and it is K plus. This is called phthalimide. Salt we got it here, that is called potassium phthalimide. And that potassium phthalimide is treated with RX. Observe it carefully. This RX is alkyl halide. What will happen? This X and this K plus is removed as KX. And then you will get a product here. C double bond O, C double bond O, N minus has been reacted with this R and it forms a compound, not as a salt. That's why NR I have written. This is N-alkyl substituted phthalimide. N-alkyl phthalimide, we got it. See the RX what we are using it here, that must be alkyl halide. It should not be aryl halide. I'll tell you that why we are not supposed to use aryl halide, why we cannot prepare aromatic primary amines by using Gabriel phthalimide synthesis. So we got N-alkyl phthalimide and that must be hydrolyzed with NaOH. A base hydrolysis should take place. If it undergo base hydrolysis, children, what will happen? Both these bonds will break. Both the amide bonds will break and it will give you OH here, it will give you H. Hydrolysis means breaking with water. And here add OH and here add H. So what we got it here? RNH2. What we got it here? RNH2. Similarly, this we got COOH and OH there also. COOH, COOH. This is called phthalic acid. Upon hydrolysis, we get that. And treating with NaOH, NaOH is also there. So we get COO, Na, COO, Na. A salt of phthalic acid we got it. A salt of phthalic acid we got. So here in amide, two amide bonds we are breaking, hence we get primary amine. Two amide bonds we are breaking, that's why we get primary amine. And here alkyl halide whatever we are taking, that must be primary. If it is secondary or tertiary, it preferably undergo elimination. It will not undergo for substitution. That's why we can only prepare primary amines. Then, sir, you said that why can't we prepare aromatic amines? Aromatic amines cannot be prepared. Aromatic amines cannot be prepared by Gabriel phthalimide synthesis. By Gabriel phthalimide synthesis, why can't we prepare aromatic amines? Children, we are using RX, right? Instead of this RX, if we use ARX, we are supposed to get ARNH2. But aryl halides, ARX, these are called aryl halides which are less reactive. Aryl halides are less reactive towards nucleophilic substitution reactions. Those are called SN reactions. Aryl halides are very less reactive towards nucleophilic substitution reactions. That halogen and carbon bond acquires partial double bond character. That means single bond has become partial double bond, means bond becomes stronger. It is difficult to break it. That is the reason aryl halides cannot involve in nucleophilic substitution reactions. If they are not involving in nucleophilic substitution reactions, in the sense, we cannot prepare the aromatic amine. Aromatic amine best example is C6H5NH2. Aniline cannot be prepared by this method. It's a very important question also. Hope you understand that. The next reaction we have is Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. A very important reaction like Gabriel phthalimide synthesis. It was given on the honor of scientist called Hoffman. Bromamide is formed as an intermediate product. Degradation, the parent compound what we are taking, right, which gives a product, that product is having less number of carbon atoms than the parent compound. That's why the reaction is called degradation. Carbon number decreases. Carbon number decreases. It is a good preparation method for preparing amines from amides. For suppose if amide is of 2 carbon, let us say, you will get one carbon amine. For suppose amide, if amide is of 3 carbons, you will get 2 carbon amine. Amide is of 4 carbon, you will get 3 carbon amine. That means carbon number decreases compared to the parent compound. So if you take amide, that is RCONH2, it is a general formula, treated with bromine and NaOH, which gives you RNH2, primary amine, plus Na2CO3 plus 2NaBr plus 2H2O. So this is the reaction can be given. So here carbon dioxide can be removed and it is formed in the form of Na2CO3. If I use KOH, I can use KOH also, you will get K2CO3. So if you observe that RCONH2 has been converted into RNH2, this CO has been degraded or has been lost in the form of carbon dioxide that is absorbed by the base called NaOH. If you use KOH, KOH can absorb it and it forms Na2CO3 and K2CO3 respectively. This reaction is called as Hoffman-bromamide degradation reaction. So these are the preparation methods can be given for amines. Hope you understand all the preparation methods clearly. Okay, so we have reduction of nitro compounds, ammonolysis of alkyl halides, reduction of cyanides, and we have Gabriel phthalimide synthesis as well as Hoffman-bromide degradation reaction. All these are the preparation methods of the amines only. Next we will see few conversions here. So how do you convert benzene to aniline? How do you convert benzene to aniline? Aniline is aromatic amine. So how do you convert that benzene to aniline? So benzene to aniline conversion we wanted. So benzene is reacting with concentrated nitric acid and concentrated sulfuric acid. This reaction is called nitration. Benzene undergo nitration with nitration mixture. Nitration mixture is mixture of concentrated nitric acid and concentrated sulfuric acid will give you nitrobenzene. Which is on reduction with iron plus HCl, which gives you aniline. That is C6H5NH2. So that is the preparation method can be given for aniline also, right? So it is a conversion from benzene to aniline. Hope you understand that. Next we have ClCH2,4Cl2 hexane 1,6 diamine. Hexane 1,6 diamine. How do you convert this? Conversions are very important in organic chemistry, as you know. So Cl, CH2 4 times Cl. First I'll treat it with KCN. If I treat it with KCN, then I'll get Cn here, CH2 4 times Cn. 2 moles of KCN I'll take it and 2 moles of KCl can be removed. This cyanide should be converted into amine. And cyanide should be converted into amine in the sense I'll use LiAlH4, reduction of nitriles. Just now we have learnt. And it gives you CH2NH2, we get it at the end. So NH2, CH2 4 times already there, and here CH2NH2. This is called hexane 1,6 diamine. Hexane 1,6 diamine. That is what they asked, right? So this compound to hexane 1,6 diamine, that is what we got it. Hope you understand. Next we have another one, benzene to N,N dimethyl aniline. How do you convert benzene into N,N dimethyl aniline? So that benzene is reacting with nitration mixture HNO3 plus H2SO4 at less than 60 degrees Celsius, which gives you nitrobenzene. which gives you nitrobenzene, which is on further reduction with SN plus HCl. It gives you aniline, C6H5NH2. It is treated with 2 moles of CH3Cl. Right? We have learned ammonolysis of alkyl halides. So 2 moles of CH3Cl, if I take it, this H with the Cl can be removed, 2 moles of HCl can be removed. Then that hydrogen is replaced by alkyl groups. You will get NCH3CH3. It is N, N dimethyl aniline. N, N dimethyl aniline. So like that we can convert benzene to N, N dimethyl aniline. So these conversions are always very, very important, children. All organic conversions, you have to practice well, especially for NEET examinations. They will ask roadmap questions like A to B, B to C, C to D. Such type of questions they will ask. A reacts with this compound, gives B. B reacts with that compound, gives C. C undergoes this process, gives D. Find out A to B, B to C, C to D. A, B, C, D, you have to find it out. So in such cases, organic conversions are very, very important. Hope you have enjoyed the session. In the next session, we'll catch up with another interesting lecture. Until then, take care. Signing off. Bye.